Subnet mask. Now we got to the point. So this is the point where we should understand, we must understand why the subnet mask exists, how do I use the subnet mask, and what kind of difference that makes if I using different mask between two hosts, for example, for two routers, for example. That's why I'm bringing my command line in here. I got 3 routers and 2 switches to help me out with that task. And let's go for the first part in here. So subnet mask. If I got one PC, let's say one PC in here, sorry, I will represent as a router because I got the routers in there. So I got the router 1 in here, let's say router 1, and the router 2 on the other side in here, router 1 and router 2. They are connected via Ethernet 0/0 and Ethernet 0/0. So R1 and R2, they are connected via these interfaces. If the R1 gets the IP address 10.1.1.1.1 and the R2 receives the IP address or has been configured with the IP address 10.1.1.2, do you think they can ping each other just with that information? They probably can, but we can never ever say that without looking at the subnet mask, because the subnet mask tells me how big is the network and how big is the host portion. So let's say for example, I'm using the subnet mask as a 255.255.255.255.0. What this subnet mask represents? The subnet mask says all bits turned on means this is the network portion, network, and the bits turned off means the host portion. So for the 10.1.1.1, using this subnet mask, this is the network and the .1 is the host. If I want to make a connection between R1 and R2 and make sure they are reachable to each other, I should give the R2 the same subnet mask, which is the 255.255.255.0, and that represents the 10.1.1 and the .2 at the end. So just reading this part again, this is the host and this is the network. Host and network. Why R1 should reach R2? Because R1, it's member of the network 10.1.1, and R2, it's inside is member of the network 10.1.1 as well. So they are on the same network. Because they are on the same network, they should ping each other. To represent that, I can bring my command line in here, and I will start on R1. I'm going to global config interface Ethernet 0/0, and I'm going to set up the IP address as a 10.1.1.1 and the subnet mask of 255.255.255.0. I will type the command no shutdown. I want to get the interface up. So let's wait for the message. Yes, the interface is up. And then I'm going to R2. R2 the same thing, but we're going to use the .2 at the end of the IP address. So interface Ethernet 0/0, IP address 10.1.1.2, and the subnet mask of 24 bits, which is a 255.255.255.0, and the command no shutdown. And now we must wait until we get this message. So they change the interface to up. So R1 now should reach R2. How do I test that? Using the ping 10.1.1.1, which is myself, R1. That's okay. And 10.1.1.2, which is the R2. I'm going to send the ARP. That's why we miss the first bit in here, because the ARP message, but the rest of the pings, it's being replied. So if I try again, and it's going to ping five pings send it, 5 pings receive it, 100%. So perfect. But why they can ping each other? Because they are on the same network. So what that means? That means if I change the network, that means if I move one of the routers to another network, they cannot ping each other. Yes. And to show how that works, I'm going to do this. I'm going to R2 and change the network of R2 for 10.1.2.2. So I'm going to quickly jump to R2, and from this router, global config, interface Ethernet 0/0, and I'm just going to type the command again, the IP address again, 2.2. Enter, and let's try the ping. Now we're going to ping 10.1.2.2, and will not get reply. Why is that? Because they are in the different networks. The router 1 is on the network 10.1.1, the router 2 is on the network 10.1.2. But there is a way I can fix that. I can change the subnet mask. I can change the subnet mask in here to 0, and over here to 0 as well. When I'm doing this, changing the subnet mask to 0, I'm moving this boundary here to the end of the second octet. I'm moving the boundary down to the second octet. So I'm doing this. Now the network is 10.1. 1.1 is the host portion. Now the network is 10.1, so they are in the same network, and the host portion is 2.2 at this site. Let's have a try. Let's give a try on this. Let's check this if R1 is gonna ping the R2, and technically they should be able to ping. So on R1, I'm going to the interface Ethernet. So I'm gonna use the up arrow, and I'm gonna change this subnet mask in here to 0, so 10.1.1.1 with subnet mask 255.255.0.0. R1 is done. I'm gonna do the same on R2, internet interface Ethernet 0/0, and 10.1.2.2. The IP address remains the same, but now the subnet mask is 16 bits. It's 255.255.0.0. Return, the IP address is done. Now we're going to try the same ping, and the ping should reply. As you can see, it replied. Why is that? Because we move the boundary to the left, so we move in the subnet mask to match only the first 2 octets. If the first 2 octets are the same, that means they can ping each other. Another thing to understand about subnet mask, it's how do we represent the subnet mask? We can represent in 2 ways, via subnet mask or prefix length. So when I'm using this subnet mask 255.0.0.0, I can represent that as a /8. So most of the books, the Cisco books and any other books, they write down the IP address, which is like this: the IP address /8. That /8 represents the subnet mask, and this one we call as a prefix length. Prefix length. Prefix length means the subnet mask. Why is the number 8? how many bits are turned on the 255000? The first 8 bits on the first octet, no single bit on the second octet, no single bit on the third octet, and no bits turned on the fourth octet. That equals 8. So I got the //8. For the most common subnet mask for class B address is the 255.255.0.0, which is the same as a /16. But why is a /16? Because I got the first 8 bits, the second octet turned on, the third it's off, and the fourth octet it's off as well. That's why we got a 16. And the third and the last one is the 255.255.255.0, which is the same as a /24. So it's /24, and it's a /24 because the first octet is turned on, the second, the third, and the fourth octet is off, what gives me a result of 32. So 32, sorry, 32. Oh, God, almost a mistake. It's a 24. 8 times 3 is a 24. So what gives me the result as a 24, so it's a 24 bit. So when you see IP address like this, 192.168.10.1 / that's exactly the same as a subnet mask 255.255.255.0. So that's how we represent subnet mask in another way that we call prefix length. For our next video, we will start the subnetting questions. So the first video is going to take, let's say, a few minutes to solve a problem. On the second video, less minutes. And on the third video, we're going to do a subnet in up to 30 seconds. And I promise that. And this is going to be really, really helpful for your exam. So looking forward for the next video, and see you there.